the derivative x to the n?
Are you going to push 5-1?
Well, it will take care of it, yep.
It's on Sunday for me right now.
It's on today for me.
No, it's not. It will be taking care of it, don't worry. So what's the integral of x to the n? Dx. That symbol means integration. Integral. What that means, what function has a derivative x to the n? That's what that means. Well, you want to do the opposite to this. Opposite to the derivative. With the derivative, remember, these are the inverse of each other. For the derivative, what'd you do? You subtracted 1 from the power and you multiplied by n. So to get back to the original one, what do you need to do? You need to add that 1 back to it. You need to add 1 to the power and divide by the new power. The only problem with that is what? And we always say plus a constant. Plus a constant. You'll see why plus a constant. The only problem with this, it does not work if n equals to what?
0.
And plus 1 is 0. So n will have to be what? Negative 1. That's the only time you can't use it. When n equals minus 1. Because if it's minus 1, you're dividing by 0. So let's look at this. What's the derivative of x squared? 2x. What's the derivative of x squared plus 20? 2x. What's the derivative of x squared minus 50? 2x. So if I said to you, who has a function that if you take or what function if you take the derivative of it, the answer is 2x. That's what that means. What function, if I take the derivative, the derivative of it, the answer is 2x. Well, it could be this, right? It could be this. Could be this.
Several possibilities.
So the answer to that becomes what? It's x squared plus a constant. That's what c is. So that's the first thing I want to talk about. And c could be a positive or negative number. It's a constant. So as long as you have x squared, c could be positive, could be negative, could be 0. So any function that has x squared in it plus a constant or minus a constant will have a derivative 2x. Let's see how that rule works here. Can I really get that answer using that rule there? If I take the 2 out, what's left? X dx. And what's the power of x right now? 1. So let's apply that rule. Add 1 to the power and divide by the new power. There's the 2 sitting outside. Let's add 1 to the power. That becomes what?
Squared.
X squared. Divided by the new power, which is what? 2. And don't forget to add a constant c. Can you simplify that? So what's your answer? X squared plus c. We knew that. It's going to be x squared plus c. So the integral of x to the n dx is x to the n plus 1 over n plus 1. We add 1 to the power and divide by the new power and add the constant c to it. And you could have more than one. If you have a chain of them, if you have 4, 5 of them, 6 of them, we still do it. Let's take some examples here.
Would x prime and x always cancel out?
X prime and x? Where's the prime?
Like the 2 and the 2 over there?
The 2 and the 2.
Well, it looks like you have x prime written.
Here?
Yeah.
That's x to the 1. Because I'm taking the integral of 2x. I'm doing this, right? So I want to write the x to the 1. So when you add 1 to the power, you know it becomes a 2. So that's not a prime. That's a 1.
So
Good.
they always cancel out? Or is there like
Cancel.
like when you multiply by 2 and then divide by 2?
Oh, in this case. But I could have something like this. I know what he's saying now. What about if I have the integral 3x to the fourth dx, right? I can pull the 3 outside. X to the fourth dx. Add 1 to the power and divide by the new power. Let's add 1 to the power of x. That becomes what? 5 over 5 plus c. Do they cancel out now? No. If I said, what's the integral of 6x to the third minus 5x squared plus 8x dx? You can actually break it down to pieces. You can say, you know what, I'm going to break it down to 6 times the integral of x to the third dx, the first piece, minus the 5, the integral of x squared dx, plus the 8, the integral of x dx. What's the integral of 6x to the third? 6 x to the fourth over 4, right? Here's the minus 5. What's the integral of x squared? X to the third over 3. Plus 8. What's the integral of x? X squared over 2. And you want to add a c to this, a c to this, a c to that. What's a constant plus a constant plus a constant? Still a constant. So we just put one constant at the end, plus c. So we're not going to put 1 for each one, because 5 plus 7 plus 13, still a constant. So we just write 1c. So that's 3 over 2 if you simplify it, x to the fourth, minus 5 over 3, x to the third, plus, what's 8 divided by 2? 4x squared plus c. That's the answer to that. So if I go ahead and take the derivative of this, I guarantee you that's my answer. That's what that means. What function, if you take the derivative of it, you end up with this, is this one. And that's one way to test it. Take the derivative of this, see if that gives you that piece. If it is, you did it right. So let me test that. Oh, my marker's here. Let me take the derivative of this, see if I end up with that piece right there. So let's take the derivative, 3 halves. What's the derivative of x to the fourth? 4x to the third. What's the derivative of x cubed? What's the derivative of x squared? And the derivative of any constant is what? 0. Let's clean it. 3 times 4, 12 divided by 2. That's 6x to the third. Minus 5x squared. Plus the 8x. Is that what we started with? Look right there. Which function has a derivative that's equal to that? That's this function. Okay, let's try a few of these using the integral of x to the n dx. So we only know one rule right now, and that is the integral of x to the n dx is equal to x to the n plus 1 over n plus 1 plus c. N cannot be negative 1. You're going to ask me, so what happens when n is minus 1? It's coming up. Well, this will be 0, so I can't use that rule. It has to be something else. And we'll show you what that answer to that is. So what about if you have a constant? So what's the integral if we gave you of 5, for example? Any constant. We know the derivative 5 is 0, but not the integral. If you want, you can write that 5 times 1, right? Trying to prove what that answer is. And 1, I can write the 1 as what? There's the 5. The 1 is x to the 0. Isn't that 1? Now let's apply that rule. Add 1 to the power and divide by the new power. That's what? 5 x to the 1 over 1, and that's 5x plus c. So the rule is the integral of any constant, c, or let's use k for that instead of c. The integral of any constant is always going to be the constant times x plus c, always. So I don't have to go through all this to prove it. The integral of 7 dx is what? 7x, don't forget the c. The integral of minus 3 dx. Minus 3x plus c. The integral of 9 dx. 9x plus c. The integral of negative 50 dx. Negative 50x plus c. So the integral of any constant is always the constant times x. Now here's a few of them to try, for you to try them. Remember, that's the only rule that we can use as of now. So when I give you a problem, you got to make it look like this. You got to think about it. How can I make it look like that? What's the integral of 1 over x cubed dx? There is no quotient rule for integration, by the way. There is no product rule.
Can we write 1 by x cubed as x power negative?
Absolutely. He said, can you write that x to the minus 3 dx? Sure I can. Add 1 to the power and divide by the new power. That's the rule. Add 1 to the power and divide by the new power. When you add 1 to the power, that's what? Negative 2 over negative 2 plus the constant c. If you don't like negative exponents, can you rewrite that? No, that's a square, you mean, not square root. If you don't like the minus here, you can put it on the top. Most computers, most books, they don't like the minus on the bottom of a fraction. So they always put it on the front, or they'll put it on the top. Let's try another one. Again, you try it. What is the integral of the square root of x dx? What do we have?
Cube root of x over 3 over 10.
Cube root? How'd you come up with that?
2 cube root of x squared over 3.
Because you can write that x to what power initially? A half.
X over 3.
So now you add 1 to the power. 1 half plus 1 is what? 3 halves, and you divide by what? 3 halves. And don't forget to add again the c. Dividing by 3 halves is the same as multiplying by 2/3. So I think what you meant the square root here. If you want to change it, you can say the square root of x cubed plus c. And if you don't like x cubed under this, you can pull an x out of it. For those people who give me that x in the front. I'm sure if you wrote this, they'll say that's fine. The software, you know. Okay. Let me take you back to Calculus 1. I mean, it is Calculus 1, but derivative, that's what chapter? Chapter 3? Yeah. We're still in Calculus 1. Because usually this chapter in Calculus 2. What's the derivative of the natural log of x? 1 over x. Is that what you said?
1 over x.
Yep, perfect. So, what's the integral of 1 over x then, dx? What function has a derivative 1 over x? It's a natural log, right? Except here we write the natural log of the absolute value. Why we put the absolute value? Because we know you can't take the natural log of a negative number. It has to be a positive number. Plus c. Wait a minute. 1 over x. What's the power of x? 1. Remember that rule says you can't use it when the power is 1. You can't use it when the power is negative 1, right? Because when you write 1 over x, isn't that x to the minus 1 dx? Isn't that what that is? So you can't use this rule for that one because n equals to minus 1. So when you see that from now on, your answer is the natural log of the absolute value of x plus c. So now if you want to modify this rule here, you can say, wait a minute, let's do it this way. It's 2 parts. If you want the integral of x to the n dx, it's always add 1 to the power, divide by the new power, plus c, and n cannot be minus 1. But what happens when n equals to minus 1? It is the natural log of the absolute value of x. So that covers both of them. The integral of x to the n dx is we add 1 to the power, divide by the new power, add c. As long as n does not equal minus 1. When n equals minus 1, we can't use that. We have to use the natural log of absolute value of x. Again, the reason for the absolute value, we know we can't take the log or the natural log of a negative number. So it has to be a positive value there. So having that in mind, this piece here, what is the integral of 5 over x dx? Very good. Because you can take the 5 outside. That's 1 over x dx. And Georgia says that's 5, the natural log of x. Again, the only part I got to keep reminding you, plus the absolute value and also the plus c. Let me give you one we didn't do yet. The integral of 2 sine of x dx. I said to you, if you remember all your derivative, it makes Calc 2 easy. When people ask me, which one's worse, Calc 1 or Calc 2? I say, if you memorize all the rules in Calc 1, Calc 2 is a piece of cake. It really is. Now, I didn't discuss this one yet, but notice we can take the 2 out. Does anyone know what the integral of sine of x dx? What function has a sine x for a derivative?
Cosine? Well, negative cosine.
Negative cosine. Yep, right? So here's the 2, negative cosine of x. And don't forget to add the c. So that's a negative 2 cosine x plus c. While I'm at it, since I'm having fun, e to the x dx. What function has e to the x for a derivative?
Natural log.
Try again. Nope.
Either that.
E to the x. Don't forget the c. I'm still in section 5.1. I'm just picking some problems. What about this one? What is the integral of x plus 2 dx?
X squared over 2 plus 2x.
Very good. The integral of x is x squared over 2. Remember, you add 1 to the power and divide by the new power.
Plus c.
The derivative, any constant, the 2 is 2 times x plus c. Always going to have that c there. What is the integral of 3x to the 4th minus 5x squared plus x dx? Anyone? Here's the 3. What's the integral of x to the 4th? X to the what? 5 over 5. Here's the minus 5. What's the integral of x squared? X cubed over 3 plus x squared over 2 plus c. So what do we have? 3x to the 5th over 5 minus 5x to the 3rd over 3 plus x squared over 2 plus c.
Didn't you go like least common denominator or something?
You can. They probably leave it alone at this point. I'm looking at your book. They'll leave it the way it is. But you can, if you want to find the LCD and make it look nicer, you can. Remember, there is no quotient rule here. What do you think? Think of simplifying with it, because you have to make it x to the n. How can I make that x to the n?
3x to the negative 1/2.
Very good. Notice that's x to the 1/2 in the bottom, right? Bring it to the top. You can end up with x to the negative 1/2 times x plus 1. Distribute that one. So what do we have? X to the power of what? 1/2 plus x to the power of what? Negative 1/2. Now we can integrate because they're all x to the power of n. You add 1 to the power and you divide by the new power. Add 1 to the power, that's what? 3/2 divided by 3/2. Add 1 to the power, that becomes what? 1/2 divide by 1/2 plus the c. This one probably, George, they're not going to leave it 3/2 and 1/2. They'll change it to 2/3 x to the 3/2 plus 2x to the 1/2. They'll leave it 1/2 probably plus c. Ready to try a couple more of these? If I gave you this one, let me change the letter instead of x all the time. Change it. So I'll mix and match letters, not always the same thing. Remember, there's only one rule we have. So what can I do here?
Can I expand t square plus 1 square as a square plus 2ab plus b square?
Oh, you want to FOIL it, you mean?
Yeah.
It says FOIL this one, multiply it by itself. So if that's what it means, t squared plus 1 times t squared plus 1. So that's the integral of t to what power? Fourth plus 2t squared plus 1. So I didn't even discuss the integration yet. I'm just doing algebra. FOIL this one. Get that one. And now let's integrate that. You add 1 to the power over the new power plus add 1 to the power over the new power, which is what, 3, plus t. Don't forget to add the c here.
We couldn't do like t squared plus 1, square plus 1 over 3, without foiling?
No,
can't.
because the derivative of this is not 2 times t squared plus 1 to the power of 1 times the derivative of what's inside that. So because of that, you can't do it. You got to break it down like this. Actually, for this problem, that's the only way to do it. There's no other way. Some of them in advanced level, we can show you a different way, but this one, nope. That's the only way to do it. If I had a t here after that, I could have do something called U substitution, but not this one. And we'll get to that probably today. So you're trying to make it look t to the n, every one of them. Otherwise, you're in trouble there. Just like if I have this. I can rewrite that as what? X to the negative 2 times x cubed plus 3. Which becomes what? X plus 3x to the negative 2. Add 1 to the power and divide by the new power. X squared over 2, very good. X to what power? Negative 1 over negative 1 plus the c. Clean it. X squared over 2. I can take the minus sign here because there's a minus here. That makes a minus 3 over x plus c. That's section 5.1. I'm going to show you 5.2, but I'm not going to do any work on it. We have something called summation, and we hit that big in Calc 3.